As you can tell, we've moved on to chapter 4. This one's broken down into 2 parts. So, of course, being broken down into 2 parts, there's no exam this week. But we're going to talk about networking and the internet this week, and then go into cloud computing next week. So hopefully what we're going to do this week is look at a computer network and the different types of communication media, devices, software needed to connect 2 or more computers together. Now, granted, you may hear the term computer node. Basically, that is just a computer or a device on the network. And businesses use computer networks to share hardware, programs, databases, everything that we've so far talked about in this class. Computer networks are fundamentally key to how information systems work. Now, the network is made up, it has a shape. It actually has 2 things. It has it says network topology, but network topology can be how it's physically connected or how the data flows logically through the network. They can be totally different based on what kind of security and what kind of equipment you have. But basically, just think of a network topology is the shape of the network, the physical network. Now, there's 3 different major categories of topologies. There's a star network, a bus network, and a mesh network. Now, a star network has a central device in the middle that every device connects to it, and every information has to go through that hub to get to a PC. So I'm going from PC A to PC B. I can't just go there directly. I got to go through the hub. If I want to go to the one right next to it, I got to go to the hub and back out. So everything goes to the center and then back out. Now, a bus network is probably similar to what we've got in a lot of our labs on campus. Is you've got a major backbone wire, and then there are a series of cables that connect to that backbone. And usually this backbone goes off to other devices. But you could make a network that just communicated amongst these 7 computers using this bus network. But it's basically computers connecting to one major throughput or connection that's used. And then there's something called the mesh network. And most of our networks today, when you think of it, not just maybe in our classroom, but when you think about the internet, it's a mesh network. And it's probably more what they call a partial net. Because a mesh network, you can have a fully mesh network, means every device is connected, has a connection to every other device. But too expensive to do that. So you end up having a partial network. So only connect some devices to others, and then, kind of just say, okay, this one's going to be key to get to another network. And so the network in the internet is built on a mesh network. Now, there are certain types of network types, and basically these are what geographic areas a network is intended to cover. A personal area network is just things that connect to you. You can think of it as your Bluetooth. You can connect your phone to yourself, to like my hearing aids are connected to my phone. I can adjust the volume. That's my personal network. A local area network is a connection of computers within a small area. The campus, your home is a local area network because you've got multiple PCs connected to a wireless router. So that is your own small little personal network. So businesses, homes have local area networks. A metropolitan area network is devices that span an entire campus or city. I think Lenore, a few years back, Google put in some networks that covered the entire city. And then you got wide area networks where it handles wide, large geographic area. So these network types are based on how much geography is being controlled or managed. Come on. Now, I've got the infrastructure, I got this topology, got them all connected. But the question, how do I get data back and forth? Well, the basic way of sharing information between a company that has a computer that has information, has a shopping mall on it or a shopping center or store equipment you want to buy from what you want to purchase, its architecture called a client server. Think of it as a restaurant, and you have a server and you have a client. So you are the client. When you sit down at the table, the server sits you and says, takes your order. You make a request to the server, and then the server takes it back to the cook, and the cook does his thing and brings it back out. So it's this client server. So in this case, you're the client, the waitress or the waiter is the server, and then the database and stuff that's behind it that has the actual content is the database that we've talked about in previous lectures. So that's kind of the general term of the client server thing. Now, the question is, how fast do I get things? Now, you got a couple of things here. You got channel bandwidth. Channel bandwidth is the rate at which data is exchanged. And it's usually covered in bits per second. You want to know how fast your network is? You can do a network test and see how many megabits per second is being transmitted up and transmitted down to you, so you understand how quickly you can manipulate this data. Now, broadband term is just a broadband communication, just a relative term, but it's more of what the telecommunications system, Charter, I think Earthlink is a broadband communication. So, but there's two different broad categories as far as the types of media. Actually, there's three different types. You have wired, they called it guided, but to me I've either got a wired network or I've got a wireless network. Those are the two major categories. Now, within the wired network, there are three different types or three different categories of media that's used. You have what they call a twisted pair, Ethernet twisted pair. If you look under the desk in your office, you will see, usually it's a gray cable, but it doesn't have to be, but in there is 8 twisted pairs that allows data to transfer from your computer into the school's network. There's a coax cable. It usually has a very solid copper internal core. It transfers data faster and cleaner, but it's definitely more expensive and harder to manipulate. If you wanted to rewire your house with Ethernet, not a big deal. If you wanted to rewire your house with coax cable, a harder job, because it just doesn't bend and manipulate well to get in the walls and move around as easy. And then the third one is fiber optic. And fiber optic is thin strands of glass that are bound together to protect it, because being glass, it's very fragile. And the diameter of this glass is about the diameter of your hair. But it is, one, it's expensive, but two, it sends a lot of data. So it has advantage of giving me a whole lot more data throughput at a higher speed than twisted pair or coax, but it's also more expensive. So you want to be careful as when you use it and how you use it. Now on the wireless side, it basically says what? I'm going to broadcast my communications through the airwaves, and through those airwaves are done through frequencies. You've used it probably your entire life, from the time you played a radio to the time you heated up Hot Pockets in your microwave. All of that, or turned on your TV. You don't go, when TVs first came out, you went up, pushed a button, turned it on, and manually turned the channels. So if you wanted to change the channel, you got up out of your chair, you went over and changed the channel. Now what do? You take the remote, you click it. That's an infrared frequencies. So you've got at least 3 different frequency ranges that are being used. Some you use to listen on the radio when you come to work. Some you use on your cell phone, and those are in the microwave frequency range. That's why if you're ever on your phone and or on your computer and somebody turns a microwave on, you get a little bit of interference. That's the reason, because they're in kind of that same frequency range. Now, in some cases, the use of this wireless communications is regulated. The FCC regulates who can be in which bands. So just know that there are certain ranges and pluses and minuses, and the table goes through all the advantages and disadvantages. Take a look at those. And then there are agencies that regulate who can be in what. Now, as far as also, you got a couple of other different types of communication devices. You got near field communication, and this is when you take your cell phone or your credit card and you go to McDonald's and hold it under to kind of read it. It's very short, very narrow, and doesn't travel very far, but it's a fast communication between 2 devices, very short. Bluetooth has I think more of a Bluetooth as within 30 feet or so, it works. I think the spec goes a little bit further than that, but in practice, I find once you get beyond 30 feet, start getting doesn't work as well. And then you got Wi-Fi. Wi-Fi, you're all comfortable with. We use it at home because you got one router that's transmitting this wireless signal over, and it's picked up by people in this area. Now, Wi-Fi is actually a brand that's used by Wi-Fi Alliance, and all Wi-Fi Alliance is a group of companies that have got together to verify that the products you buy match the latest and greatest IEEE standards. And as long as the product matches those standards, it gets the Wi-Fi approval. But I think right now we've kind of turned anything Wi-Fi as anything that's in the air, but that's not true. Here are some of those IEEE standards that Wi-Fi tries to measure its standards up. And each of these, as you can tell, has certain speeds and certain frequency ranges that they operate in. Some are in the 2.4, some are the 5 gigahertz range, some are both. When you start getting down to 802.11ac, you're starting getting up in the gigabits range very fast, but it's able to handle both, can transmit either 2.4 or 2.5, and so based on how fast you want to try to run. Now, sometimes you're going to see microwave transmissions. You've seen along the highway where you see these large towers with a big antenna on it. Well, sometimes it's very expensive to run cable connecting certain computers together, but I can get a line of sight between one tower and another and get data through quickly. So all I had to do was build the tower. Another use of it is geosynchronous satellite. It's a low orbit satellite, something that's geosynchronous. It sits up about 25,000 miles, and it looks like it's stationary as far as the Earth is concerned because it's rotating at the same pace we are. But you can transmit your TV stations, news broadcasts and stuff are all sent up geosynchronously. There are a couple of, I think Motorola at one time tried to get a phone system that was based all on satellite. And then low Earth orbit is you put a lot of satellites closer, a little bit faster communication, because these geosynchronous satellite takes about a quarter of a second to get up, a quarter of a second to get down, so there's a lot of delay. So if you're sending a lot of data, it may make it impossible for you to like that history. Now, I'm not going to go through the history of each of the generations. You've heard a lot of advertising about manufacturers getting up to 5G. Well, guess what? 5G is just the next evolution in getting us faster wireless technology. So you got faster data rate, better security, more features. So it allows us to communicate wirelessly better. And here you got the same type thing. 2017, yeah, that's probably pretty close. I think most of the companies are just really hitting it. I mean, they were probably in test markets back then, but right now you're starting to see most of your major deployments, Sprint, AT&T, T-Mobile, or advertising, trying to get nationwide 5G, all because they can get faster data rates, take up less power, so you get better battery life, and so on. There are other devices. I'm not going to go through these, but these are some other devices that are used inside as far as communication hardware. Now, the question is, I got all this equipment, and we've talked a little about software. Guess what? Networks have software too. They have a network operating software. They have software that runs underneath it. If you've finished the software section in that first section in the Google IT, you've played a little bit with Windows and Linux just to go through and play with that. And then you got network management software that kind of verifies and protects information to make sure that it's not downloaded illegally and things of that nature. Now, you have mobile device software, and you got a software-defined network. This mobile device management system just troubleshoots mobile devices remotely, pushes out app updates, and sends data and patches. So it's just a central control that handles general policies and security for a company that's managing mobile devices. A software-defined network is, we're getting to the point now where I don't need to change my physical network as much, but I can make tweaks to my network via software. I can change by a control center. I can change how the data, the network is working. Define it software. Think of it if, rush hour traffic going into New York City. Maybe I would like to have in the morning, I'd like to change more of the traffic in one direction than when it's rush hour leaving the city. I can change some of the network capacities to handle traffic going in a different direction. So it's just a way of, now somebody remotely in a computer can manage this without actually having to have physical access, to the devices to make any changes or modifications. Now, we've all used the internet or the World Wide Web. If you've gone through the Google IT section, they went through and explained the differences. We know that the internet is worldwide. It has had profound impact on just about every aspect of our life. Some countries try to censor that information that's flowing through. Some, like the United States, we probably do less censoring, even though we do see Google and others, Facebook, trying to censor some information, or at least try to verify its accuracy before they publish it. All of that stuff is things that we'll be dealing with from now and into the future, as to who has rights to the data and who can control it, who can send it out. Now, a little history. There's a system called ARPANET. ARPANET was a project started back in the late 60s by the Department of Defense. It connected major universities together to help research at the time. And then you see, things like the Internet Protocol, and basically all that is then how do I address machines? Now, the internet backbone is basically just the high speed of communication links. The IP protocol is just the rules that I'm going to pass information back and forth to each other. This transmission control protocol just says, how am I going to control the flow of information between the two? Am I going to make sure every packet gets through cleanly with no errors, or do I just send it on through without doing any error checks? There are a couple of different IP address formats. There's a IPv version 4 which is only a 64-bit address, and an IPv6, which you'll see more and more of since the last IPv4 address was assigned probably, I don't know. I'm thinking probably back in 2010, 12, somewhere in that ballpark. So it's been, the last one's assigned, so we've had to put a lot of changes, modifications in to allow all the growth in Internet of Things and other devices to be able to address each other. Now, this is just an example of how messages could get routed to one another, where you've got a computer that's connected to a router, which then is connected to another router. So all of these routers are trying to communicate to each other, saying, "Hey, this person is trying to get to a person down here. I'm host computer 1 is trying to get to host computer 4, but it doesn't know how to get there, so it says to this router, and it sends out information, says, hey, are you it? What's the best way? What's the best route to get to this device? And these routers have routing tables that tell me which networks are connected to it, and if it's not in that table, it then sends it to somebody that may know who it's connected to. Now, we all put together typed in a web address into a Google search. That's basically called a uniform resource locator. So it's basically just a web address. And in that, it just maps the name you type in into an IP address in a host location. If we got far enough down into it, it would know exactly which computer on that company's network it had. And the company that manages these addresses, or this organization that does it, is the ICANN organization. They're just handle, and it's broken down into several different layers in how it works worldwide. You've seen those, .org, .net, .gov. All of this stuff was defined as far as by the ICANN organization to make sure that we can kind of control how much traffic is flowing to where, and just a better way of managing it. Now, how do I get to the internet? You can connect to a local area network, which the local area network connects to an internet service provider or an ISP. Mine at home is Charter, but there's several others out there. So when I send a message or check an email at home, I go from my phone to my local router because I'm using Wi-Fi to connect to it. The router says, oh, it's not inside the house, so I need to go someplace else. So it sends the information to the ISP to provide all this information. So just to give you a rough idea, that picture that several different ways data can get from point A to point B across different areas. So there's, how do I access the internet? I can dial it up. I can do cable modem. I can do Earthlink's DSL. I can do satellite communication. You can do wireless connection. So there's a lot of different ways you can access the internet. So hopefully this gives you a brief summary of network fundamentals. Check the Google Moodle. I posted links and videos there that should help and clarify some of this information. If you have any questions, let me know. Have a nice day. Bye-bye.